Welcome everyone. Today we are covering section 1.8 of the ISTQB CT-AI syllabus, pre-trained models and transfer learning. In this session, I'll explain the concepts clearly with examples from a tester's perspective. Let us begin with understanding why pre-trained models are important in modern AI systems. Okay, so imagine building an AI system completely from scratch. You need massive data sets, powerful GPUs, high cost, and significant time. This is not practical for most organizations. A pre-trained model is already trained on very large data sets. It has already learned general patterns such as edges in images or a grammar in text. For example, a model trained on millions of images already understands the shapes and object structures. So instead of starting from zero, we reuse the existing knowledge. Now let us see some examples of pre-trained models. In computer vision, models such as ResNet or VGZ are trained on ImageNet dataset. They are already recognize common objects like cars, animals, and buildings. If you are building a plant disease detection system, you can reuse such model. In LLP, some models like BERT or GPT are trained on massive text corpora. They understand grammar, sentence structure, and context. You can adapt them to build chatbot or sentiment analysis systems. So now let us see some benefits of pre-trained models. The first benefit is faster deployment or the faster development. The second benefit is reduced infrastructure cost. The third benefit is better performance with smaller data sets. For example, a startup building a face recognition attendance system can reuse a pre-trained model instead of training from scratch. So this makes AI practical and scalable. So now let us see what transfer learning means. So transfer learning means adapting a pre-trained model to perform a new but related task. For example, uh, suppose a model is trained to classify animals. You want it to classify only cats versus dogs. You keep early layers unchanged because they detect edges and shapes. You retrain only the final classification layer. This adaptation process is called transfer learning. And now let us see why transfer learning works. Each layer learns general patterns such as edges and textures. These patterns are useful across many tasks. Later, layers learn task specific features. For example, edge detection is useful whether detecting a tiger or a house cat. So we reuse general layers and adapt only specific layers. So this is where transfer learning is efficient. So now let us see the types of transfer learning. So there are mainly two approaches. Future extraction, like freeze the pre-trained model and train only a new classified layer. So this works well when the data set is small. So fine tuning, unfreeze some deeper layers and retrain carefully low running with a low learning rate. So this is useful when the new dataset is larger or slightly different. So now let us understand the risks of using pre-trained models, which is very important for ISTQB. So the risk one, which is bias. If the original dataset was biased, the new system inherits that bias. For example, a face recognition model trained mostly on one ethnicity may misidentify others. And another risk we can take as a domain mismatch. If the training data differs from production data, so the performance drops. And now the third risk we can have overfitting when fine tuning with very small data sets. And the other risk we can have licensing restrictions on commercial use. And the last risk we can have, such as the security risks, which is poisoned or the compromised models. And now let us see the, the risks in transfer learning. So negative transfer. Performance decreases if domains are very different. For example, a natural image may not work properly for medical x-rays. Catastrophic forgetting. So during fine tuning, earlier knowledge may be lost. There can also be explainability and robustness issues. So now let us understand from the testing perspective. So, as AI testers, we do not validate only accuracy. We must verify data sets compatibility with real world conditions. We must test fairness across demographics. We must evaluate robustness under noise and environmental changes. We must verify legal and licensing compliance before release. So now let us summarize what we have learned so far. So pre-trained models reuse existing learned knowledge. Transfer learning adapts that knowledge to new tasks. They reduce cost, time, and data requirements. However, risks like bias, domain mismatch, and security might be tested carefully.